Hi, Bl.3. Um, as you know, I have this worksheet up on Google Classrooms at the moment, and you're expected to do some questions there for the deadline. So I said I'd just have a quick run through it with you for a few minutes here to give you a quick overview to recap over Dochúlacht the probability from last year, and to bring it again forward into this year and see what's new and what we should know already. So if we look at the first page on the worksheet, it talks about, gives us all the keywords that we should know already and we will be moving on to. And then it moves us down straight away on to look at what we call the fundamental principle of counting. So the fundamental principle of counting is what they look at in worked example 3.1, and it's simply looking at multiplying the outcomes of two separate events together to get the total probability or the total amount of outcomes for when you look at two separate events or more than two separate events. So this worked example 3 says a 6-sided die is rolled twice and a coin is flipped twice. How many outcomes are possible? So for this it says, or for this we need to know that, well, there's 6 different outcomes for the 6-sided dice. Obviously all the numbers 1 to 6. So that's going to be, my first roll is going to be, there's going to be 6 outcomes. For the second roll again, I can have 6 outcomes again because it's the dice again, so there'll be 6 outcomes again. And then we're about to flip the coin twice now, so you'll have 2 outcomes for the first flip of the coin and 2 outcomes for the second flip of the coin as well. So your total outcomes will be 6 by 6 by 2 by 2, and that's equal to 144 possible outcomes. Okay, that's the fundamental principle of counting done. Okay, let's look at some other examples that you could have for the fundamental principle of counting. So it often comes up where we look at like a code. So let's say a 4-digit code. For the fundamental principle of counting, okay, for the numbers from 0 to 9. So if you count up on your fingers the numbers 0 to 9, there should be 10 outcomes. And for the 4-digit code, I'm going to do it 3 times. So for the first one is if there is no restrictions. So if there's no restrictions for a 4-digit code, I can use any numbers in the keypad, so any numbers 0 to 9. Well, I could use 0 all the time. So I have any one of the 10 outcomes for the first digit. And again, I can use any one of the 10 again for the second digit. And it's a 4-digit code, so I have 10 by 10 by 10 by 10. Okay, and that would give me 100, 1000, 10,000 as your answer for that. Okay, and that would be a 4-digit code with no restrictions. The second way it could ask me is a 4-digit code, but numbers can't be repeated. Or digits can't be repeated. So again, when you're doing this code, if you're going to pick that code, you'd have 10 outcomes. You could have any one of the 10 outcomes for your first digit. But once you've that digit chosen, there's 1 gone, so you only have 9 outcomes for your second number. And again, once you've that done, there's another 1 less, so there's going to be 8, and then 7 finally. So it'll be 10 by 9 by 8 by 7 if digits can't be repeated. So 1 number gets taken out each time. And that would get me a much lower number of 5040. And let's look at one other way of writing it. So what if it was a number greater than 9,000? So See, that's my 4-digit code there, 9. So it's any, so to pick any digit, but it has to start with. We can see there it must start with a number 9 or greater. And we'll see there one's the digits 0 to 9. Well, 9 is the highest number. So I know my first digit must be a 9. So you see I wrote down 1 there for my first digit. That's because I only have one outcome I can choose for, the number 9. Okay, that 9 is gone now. So that means I have to take one digit out of all my outcomes. So that means I have 9 outcomes left. And then I have 8, and then I'll have 7. So that one is a little more tricky, okay? If that one is going to catch you out, that's, I guess, the higher end of looking at codes like that for outcomes. So it can also be called permutations. So that'll be 504. So everybody make sure that you get this much. And for the last bit, again, don't get too bogged down by it if you find that tricky. Just send me an email to say, look, you didn't get that last bit. If you can't, if you find that tricky, okay, but that's again probably your part C of a question. Okay, let's go back to, so that's fundamental principle of counting. Sorry, I meant to go on, there's one last thing on fundamental principle of counting, and that is ways of arranging a word. So let's take any word. I'm just looking around the room here to see if I can see something. There's a doll's house, so I'm going to use the letters of the word house, House. And I'm going to try and rearrange the letters of that word house in any way I can. So it's how many arrangements is what I'm asking. How many ways can the letters be arranged? And again, you're only looking at this through the light of how many outcomes. Okay, so it's 1, 2, 3, 4, 5 different letters. So my outcomes will be 5 by 4 by 3 by 2 by 1. So again, throw that into your calculator to get your answer for that. Is equal to 120 outcomes. Okay, so that is your fundamental principle of counting. That's the first thing that you're going to look at when you're answering questions on this. Other ways it could come up would be like a menu, like if you have 5 starters, 4 main courses and 3 desserts, you're just multiplying your 5 by 4, so your amount of starters by the amount of main courses by the amount of desserts, to get the total amount of outcomes you could have. So there's lots of different ways to ask questions on the fundamental principle of counting. So make sure you spot all the different ones. The second thing this chapter moves on to, so I'm just going on to probability now, and I'm going on to page 41. And look at the probability scale. We've done that a good bit in class, so I'm hoping that's okay. If not, come back to me with an email or a question. And it's looking at relative frequency. So you'll see there to have a formula for relative frequency, and it is the frequency or number of times an event happens in trials over the total number of trials. So to give me an example here of in a survey of 1,000 households, it was found that 650 households had a pet. If a household is selected at random, find the relative frequency that the household does have a pet. So it says 650 have pets out of 1,000. So you'll see there it's the total number of households, the number of households who have a pet over the total number of households, which is just 650 over 1,000. And leave it then as a fraction, a decimal, or a percentage. So my fraction in its simplest form is 13 over 20. My decimal is 0.65, or my percentage then is 65%. Okay, I'm hoping you can convert. Your calculator will convert from a fraction to decimal, and then I'm hoping you can convert from decimal then to percentage or fraction to percentage. You just multiply by 100. Okay, and then from there, it's going to move on ahead. We're going to move on an extra step. So there are going to be some questions on relative frequency. You'll see those in the the exercise at the end of this. I'll just go back to another relative frequency one there for a second. So I'm going to say a dice was rolled 180 times. So I rolled the dice 180 times, and the number 5 came up 45 times. Okay, first thing is just find the relative frequency. Okay, os square is a minikiat cognesta. And it's just going to be, again, the amount of times your outcome comes up. So again, how you'd write this would just be P in brackets of a 5. So that's just the P stands for probability of a 5 is equal to 45 over 180. That's my relative frequency. Again, I'm sure that can be simplified down to a simpler fraction. And it's just 1 over 4. And I know 1 over 4 is just 0.25 or 25%. Okay, any one of those you want. It's okay with me. Okay, perfect. So let's go on a bit from this. So that's your relative frequency, again, just looking at rolls of a dice. From here, the book is going to go on ahead a little bit. So, sorry, now I'm just going to find out where I am. So the book is going to go on and look at fairness or expected value and see if it's fair. So, looking at this dice here, do you think it's a fair? So you have two options. It could be a fair dice or a bias dice. Okay, so this could also be unbiased. So is it bias or unbiased? Fair or bias? And this bias stands for not fair or leaning in one direction. How do we check in relation to this dice that I rolled? So is this fair or not? So there's always an argument, whatever you say, but we try and link it back to our expected, or we try and link it back to what a fair value would be. So we know there is 6 sides in a dice. So really, the P of a 5, let's put P up there, of a 5 should actually be 1/6 because there's 6 sides, so it should be 1/6. If you change that to a decimal as well, it can often be easier to spot if it's fair or not. And this decimal is 0.16. There's a dot over that, so 166666. Okay, so if you look up here, is there a big gap between 0.16 and 0.25? Yeah, I would say there's enough to say it's probably like a bias dice. So that dice is obviously leaning a little bit towards landing on 5 through whatever way the casino or the person has it weighed or weighted, that it looks like that 5 is going to come up more often than it should. Okay, and that's all that's saying. So obviously that would just be 16.6% as well, if you wanted to start. So there's nearly 9% of a difference there. So that would be unfair, and that's how you check it. So you check it from your probability that you actually have versus, or what we call the relative frequency, versus what it should actually be if you know that, or if you can work that out. And a lot of times you can. Okay, just through what you know yourself. So that's what we look at if you're checking to see if something was fair or not. Okay guys, I'm going to leave it there for the moment. So there's going to be some